Hey! Can you be quiet for a minute, please? So, we're talking about the barometer, right? Okay. In barometer is the one, the yellow arrow you see, this is the one air pressure is moving down. So for any circumstances, if it is rainy or cold weather or cloudy weather is getting, so air pressure is going to push down. So the height of the mercury would be lower than regular day, which is sunny day, that would be upper. So any day, if it is like today, it's going to be 760 millimeter hot, which is mercury, 1 atmosphere, that would be like this shape, right? And this is, should not be confused with this, how it look. It look like a completely unsafe, but if you have one in your home, why don't you make a like completely protected cover that will be safe, and if you like weather, you can always see the update what's going on when you get out from your home. And the next one is also called manometer. The manometer also same as barometer. As you see, the height is going up or down depending on how much atmosphere pressure is. And then we'll go a couple of vocabulary, new terms, pressure, how much force is exerting by the by the gas molecules on the surface of the container per unit area. That would be the pressure, and is in the ATM, atmospheric pressure. And as I said, pressure have 4 units, right? What are they? Torr, millimeter mercury, Pascal, and ATM. Again, not ATM machine, ATM. I focus ATM so many times because this is very important for our equations. Some equation you have to convert it to ATM. Sometimes you don't have to, but you can do all the time if you want to. There are some equation you have to have in ATM, atmospheric pressure. I'll let you know when it comes the equation. And Kelvin would be the temperature. C, that is centigrade, sometimes will be given in Celsius, but you dare not try to move to other unit except Kelvin. That means always have to be in Kelvin in this gas chapter. So in gaseous state, any formula, any equation you use, it have to be Kelvin. So you dare not to try to any others. But you understand the pressure is okay a lot of times except ideal gas law. In ideal gas law equation, you must use pressure in ATM. And then volume, the size, volume of the container is going to be in liter, and the mass is going to be in gram. Moles. What is moles? What is mole means? Did you have moles problem before? Yes. Yes, you did. So that's the mole is number of moles, right? For any molecule, any atom, any gas. So that will be N. Remember that N moles we use one other purpose. What are the N we use? N we use for multiplier. Remember you did empirical formula and molecular formula, and you said multiplier. So should not be confused about the 2N. So this N is number of mole, but multiplier you might go for X. Say multiplier X equal to mass of molecular formula or mass of empirical formula. So should not be mixed up with 2. But there is couple of M, couple of mass involved. What are they? So I just want to make sure that you can distinguish among them. So if you have small m, that will be mass, for sure, simple mass. But we have a capital M. What does it mean? What it stands for? Molarity. If you have double M, that's called molar mass. It could be one capital, one small, that's same thing. Molar mass, same. But this one is molarity, this is mass, so make sure you know the proper unit, right? As I said, for the multiplier for molecular equation, you might use X, so in that case, should not be mixed up with number of moles, right? Okay. And standard condition, what is standard condition means? STP, what does STP means? Standard temperature and pressure. What do you like to say other way?
I can't think today.
Okay, so isn't it so nice? Look at that. STP, for any gas, any sort of gas you consider in STP, their volume will be 22.3 liter, their temperature will be 0 degree centigrade, 273 Kelvin, their pressure will be always 1 atm. That's going to be always. So whenever you have STP, this is the condition you're using in any form of equation in the gas chapter. Okay? So first formula, first theory in this chapter we'll be learning is Robert Boyle's law. So Boyle's law is here. If you decrease the volume, you increasing the pressure. So if you one increase, other one must be decreased. What is called? It's called inversely proportional. It's called inversely proportional to each other. So let's get an analogy. If I let you guys move in this classroom randomly as much as you can, what will be happening? Colliding with each other, isn't it? How about if I let you guys go, hey, let's go to the next room, which is 1/4 size of this room, and you guys still keep randomly moving in any direction. You guys gonna be bumping, colliding with each other, as well as the wall. So making a force, it just bump a lot, and that amount of force per unit area, that is called the pressure. When I said, that means if you decrease the volume, you're increasing the pressure. Make sense? One thing I want to let you guys know, be clear about it, that this chapter is very simple when you look at it. When you, even last semester, when I got the quiz, they got the lowest score. What's the gap? Where is the gap is? The gap is, I said in the first chapter, first class or second class, that in chemistry is very easy to learn, but much easier to forget. Remember that every chapter you have hundreds of concepts, unlike physics, I can say. Physics is critical all the time, but when it comes to the concept, they don't have wide millions of zillions of concepts that chemistry has. So what I asked you to do, I said that before, always make an analogy with everything you're learning. If you do not make an analogy, you will forget. How many acids are strong? 6. You memorized it, right? Of course you did. I'm sure before exam comes, you will forget that. What is the solution? This is very small example I'm giving, so you might really could keep memorizing. But whenever it comes to the reactivity of the atoms, metals, whenever it comes to, I gave bridge, remember bridge, the word? I made some bridge for you guys, right? I did. Sometimes I said, okay, follow this bridge to remember that. Anything is confusing, you forgetting, use some kind of bridge to your understanding and the fact. So whenever you forget, you follow the bridge and figure out what is exactly it is. So here I would like to give you a bridge too. Simple, Boyle's simple law, but you'll forget in the next class. Forget about exam. So I get a simple trick here to remember. This is not enough. What I said bridge is, okay, bridge I said, for instance, pressure and volume. And this law is Boyle's law. Do you see the word boiling? Something boiling? What involves boiling? Temperature. Whenever Boyle's law comes, out of PTV, T is constant. T is constant because boiling, just make a bridge. In Boyle's law, boiling, T is constant, right? Then if T constant, other two, pressure and volume, they are inversely or directly. You remember the example I said. Whenever if you compress it, pressure must rise, right? Or you can remember by this trick too. If T is constant, I put T in my pen, right? If pressure goes high, volume goes down. Volume goes down, up, pressure goes down. They are inversely proportional. Is it cool? Yes. And this is the way you can remember this. Trust me, very simple concept you forget because this is not the physics. Of course, you learned that formula in the physics too. Ideal gas law, physics have different way of explanation. When you come to us, we are not learning only the gaseous laws. We're learning a lot of other laws and concepts. So, anyway, so if this happen, the formula goes PV equal to, so P1, B1 equal to P2, B2. This is the Boyle's law formula. So I have two actually unit, two terms, pressure and volume. Initial and final stage, right? In so always two scenario. One scenario, pressure is one pressure, and then later on another pressure. One volume, second volume. So if you have some out of 4, if you have 3 values, you can get other one. How to solve the problems with this formula? It's very simple. You get the 3, get the other one. Plug in the values you have, and find the one you don't have. And there is some graphical way of presentation. Look at that. If you volume decreasing, pressure increasing. Pressure decreasing, volume increasing. This is also you can see pressure increase and volume. Pressure say increase. Did I say wrong, right? Okay, I'll correct it. So decreasing pressure. Too much trouble? Okay. So actually there would be decreasing pressure, volume increasing, right? Okay, how do you solve it? Look at that, gas occupied this volume, which is V1, and pressure 751, and temperature is, final temperature is 21, and the volume, what is the volume? So let's see what you have. You have the volume. Whenever you see the volume, start writing V1. You don't worry about which one V1, which one V2. Just keep writing as a V1, which is 38.7 milliliter. Then you have milliliter mercury, 7, which is P1. So 751 millimeter mercury. And then what is the volume? It says temperature, right? Let's write it. So just to make you guys easy how to solve the problems. So it says 21 degrees Celsius. So remember that Celsius, we don't keep it. Always need to convert it to Kelvin. How do you convert to Kelvin? Exactly, plus 273, which is 294 Kelvin, right? And then what is the volume? So since we got one volume earlier, this one would be V2, right? So I'm following exactly the order it says, so that you don't have to go back and forth making V1, V2, no. Just follow it in order. So V1 is unknown, and then pressure is going to be P2 because I already got P1 before. So P2 would be 359 millimeter mercury. Temperature remain constant. What does it mean? Temperature is going to be same. So which laws I can use? If T is constant, P and V. If T constant, that means Boyle's law. So this is we can use. And what did you write T1 before? If you write it up, you don't have to worry about which law you're going to use. Because since T is constant, now I don't have to worry about this T anymore. Right? Then you plug in the values that you have. 1, 2, plug in the value. So P1, V1, and P2, find out the V2. Just as I said, find out the one you don't have and plug in what you have. And if you do that, so if you rearrange the equation, V2 would be P1, V1 over P2. So P1 is 751. Question: do we need to convert millimeter mercury to atmosphere? No, you don't. You don't have to. How about you do that? That's also okay. You can convert, but you don't have to. 751 millimeter mercury times V1 is 38.7 milliliters, and P2 I have 359 millimeter mercury. Look at that. If you had two values, P1 and P2, V1 and V2, at that time unit is going to be same whatever you take it. Because if you divide by 760 both sides, answer is same. But you look at what you have option for multiple choice questions in terms of exam. In exam, you look at your answer first, whether it millimeter mercury or atmosphere. You can convert it initially, or you can calculate after that. Like for instance, volume here. Volume I have in milliliter. If your answer choice you have in liter, then you can convert it right now, or you keep it until you get the final volume, and then you convert it and pick your choice. So you put the values, and then finally you cancel out the unit of mercury, and then answer is 81.0 milliliter, and which is 3 6 here. Again, if answer is in liter, at that point you dividing by 1000. Then you choose your answer. What is Charles' law, guys? Anybody? Pressure is constant. So if I put pressure is constant, I want you to figure out. Look at that. I keep it constant, right? I move it. Look at that. If I move, let me put it all the way down. If I move it up, T also move it up. If I put V down, T also going down. Then V and T move it together. Up, up. If other one go down, both go down. Right? That means P1 increase, other one, which is if P constant, if V increase, T must increase. The T decrease, B must decrease. So as you see, the volume was 2.26 liter. Now volume increase, and then temperature also increase. Or other way, if you heat it up something, it become expand. because if you heat, increase the temperature, volume increase. So they are directly proportional, and the equation is V1. Let me make more space for you here. V1 over T1 equal to V2 over T2. And this is the equation for Charles' law. As you see, increasing temperature and volume also increasing, right? It's a graphical way. So this relationship will not establish, will not sustain until P is constant. This is another graphical way. So how about the problem? How do you solve the problem? When you solve the problem, you do not worry about the language. You worry about what you have been given. So read out the questions and then write the values what you have. Look at it. So you have the volume 79.4 of carbon dioxide. So you have V1. So you have V1, which is 79.4 milliliter, and then T1, which is 0 degree centigrade, and P1, which is 760 milliliter Haque. And then how many milliliter of gas? That means volume. We got V1. Then we should write V2 is unknown and T2 also given. So T2 is 27 degrees centigrade, which we have to convert to Kelvin to 73, which is 300 K. So, and T1 is 0 degree, that's also added with 273, that will be 273 Kelvin. And so what I have in here, look at the V1, V2, and T1, and so V1, T1, and V2, T2. But P1 is 760, but I don't have P2. That means P did not change. So we don't need that. And if you plug in the value, what you have, you see, out of 4, as previously we did solve it, out of 4, 3 is given, you get the fourth one. Right? Get the fourth value, and which is the volume. Any question? Okay. How about combined law? How about this Boyle's and Charles' both law is combined? Then what do you get? Let's see. If you combine together these two equations, right? What do you get? So P1, V1 in the upper side, T1 in the bottom equal to P2, V2 over T2, right? That's what you have. So this is the combined law. So out of 6 variable, you get 5, calculate the 5th one, calculate the last one. What if you don't have temperature change at all? What are you going to do? So exactly. So if you just cover it up temperature one, it's going to be Boyle's law. If you cover it up with pressure, it's going to be Charles' law. So you use it as needed, based on which is variable, which is constant. So can I ask you to solve this one? Okay, do that. And if anybody is willing to do the board, get some extra credit, please. Oh, she's already started.
No, the temperature is not given.
Yes, yes, sir. Yes, sir.
If the temperature is not given and we are in need for it, it's always estimated.
Temperature is,
If it's not given and we need it.
then we don't worry about it until stage STP. If it says STP, then you use standard, which is 0 degree. Yes, don't get wrong. That's it, teach. Can you walk in? Yeah, we teach. That's good. What's up with you guys? Solve it? Fantastic. Oh, what's that? But I think I did not post the answer, did I?
Yeah. No. You didn't post the answers.
For this one?
Yeah.
Did you get the answer there?
Yes.
Awesome. When did you download the PowerPoint? A few days ago?
Yeah.
That's one.
I took it from my downloads.
Yes. You downloaded all of them before?
Oh, I turned it into PowerPoint, and then whenever I go into my downloaded folder, I already had it.
Please delete them out. Otherwise, it's going to be hard for you to learn it. Because I want you to not to have the answers, practice it by your own.
It was hard.
Yeah. And I purposely deleted all the problems
Oh, yeah.
2 days ago.
Oops.
Okay, so let's see what she did. So I got the V1. Look at that. Let's see what we have. We have the first one is P1, right? P1. Then the depth. What's the depth? Why is saying depth? It's a ditch. Don't be thrown off with it, right? Just a trick. And then temperature is. You have temperature first one? Yes, 4 degree, which is to 77 Kelvin. Wonderful. And then V2, do I have V2? We need to calculate. That's the unknown one. And I have P2, 1 atmosphere, and temperature T2, final is 11. So plug in all the values we have. Only thing for the equation, let me write down the equation. So this is the equation we have, right? So if you plug in all the value in the equation, that only thing is not given is V2. So rearranging, that gives you V2 value. Any question? Okay. Then we can go to the next problem. There you go. Okay, next problem. I have this one for you. Okay, please go ahead and solve it. Anybody can solve on the board? Okay, go ahead.
Yay. I don't want to. Should we do it over here? How many erasers? This one?
Yes, you might keep the equation. Yeah, this one you can take it out.
Alright. It's on the PowerPoint.
What's that?
It's all
No,
on.
as I said, I changed it 2 days ago when we started. So if you download earlier, you got it. Otherwise it's not. So you better to do it. Okay. No.
Finding the exact thing you really don't.
So maybe we can add something that you have to explain that. Yeah? We can add up something that you have to explain that up. So that you can know whether you understood or not.
When we learned this in physics too, so
You took recently?
I took physics.
When?
Okay.
I want to see your grade in quiz 5. If I can show you the quiz 5 grade for my last semester, I can show you now. You'll be surprised. same teaching, same material, same PowerPoint.
Hopefully when you grade our quiz,
PowerPoint,
it's better.
I did not make PowerPoint. I just, I just transfer from semester to other semester. And this is the same person. And people got 3, 30, 40. Yes, there is. So only thing is they confuse with the Boyle Charles, they confuse with the ideal gas, they confuse with the units. Kelvin is the one I did not.
I took all of this in
I thought they'd get more confused with pressure.
Physics 1 is, Physics 2 is not.
Sorry, I'm trying to find it.
So,
College physics?
okay, go ahead. You got the B.
That's a university physics.
Good. You got others? Yes.
University
Keep
physics
going.
and college physics.
No, one in 40, 25, 24 to 26.
Something like
So there's unit 1, 2,
No, they depend.
No, 1 and 2, that's university.
When you transfer over to university, they don't accept college physics. They usually accept university physics. There's two classes. They sound similar, but they're different. University physics is like most stuff that transfers over, like where I'm going.
No.
okay, you could go.
Make
Oh,
sure
you
that
need
you
to
know
get
where you
that.
transfer to, that they accept college physics, because most don't accept university.
You need to be more careful.
So before going, okay, guys, before going to the problem, I'll explain the problem again. But before going there, I just want to go briefly about ideal gas law. What is ideal gas law, by the way, guys? What is ideal gas? Perfect, right? No mistake, no flaws, right? So ideal gas basically by definition is the gas which follow Boyle's and Charles' law 100%. That's called ideal gas. So this is the ideal gas law, PV equal to nRT. So my question is it really something possible to be ideal? No. Is there any ideal man in this world?
Yes,
Who is this?
someone.
Someone, right? It's about the belief, actually, by the way. If you believe in God, God is ideal. If you believe in, some religion says some prophet or, perfect ideal. Of course, this goes with the belief, of course. But in reality, not ideal man possible in this world. I don't know about the past, the prophet and belief, but in this world, ideal gas, everybody say, I am perfectly perfect, or I am, not perfect, whatever. So same way, ideal gas is not possible. But if there would be any ideal gas following all Boyle's and Charles' law, there would be the equation PV equal to nRT, solving their pressure, calculating volume, calculating number of mole, RT. So this N is the mole, right? R is gas constant. So gas constant R, the value you have in here is going to be always. So